Hello everybody, welcome back. So in the second part of this week's lesson, we're going to revisit the video grid and slit scan examples we just developed, except this time we're going to talk about how we would keep a record of all the video frames that have come in so that we can create sort of animated versions of these effects. All right. So this is our slit-scan program, and before I remix it, I'm just going to show you a couple of things. I went ahead and I added the other video files that we had. So it's a bit of a clunky system, but if you want to try different video files, just uncomment one of the lines. This is the other another one of the videos I had brought in that represented this harbor time lapse. And this one is kind of cool actually with the slit scan. As you move your mouse around, you can kind of paint with different lines that create the building structures. So you're kind of recreating a new version of the landscape that doesn't really exist. So kind of a cool effect. And if you just leave your mouse there, of course, you will get, because there's not a lot of motion in that scene, in the time lapse, you will get some pretty constant lines, except of course you get a sharp drop here when it goes from day to night when it loops back. And there's a few little interesting details that start to emerge. This is where basically where there's motion. So some of the clouds have motion in them, and depending on where you're sampling, you're going to catch different things. So anyways, so what we're going to talk about in this lesson, right, is how do we capture the video so that we can create sort of animated versions of these effects that are a little bit more fluid. And by capture the video, what I mean is that while we can play a video file in P5.js by using create video, and we can also have access to its pixels. If we do load pixels, right, we could do some calculations based on the content. Once the next frame of video comes in, the previous one is kind of overridden in a way. So we only get to have access to one video frame at a time. And that can be sort of limiting because it would be fun if we could have access to all the video frames, right, that are part of this video at once so that we could combine them in the same image. We could draw different slices using the slit scan technique of our video, but sample them from different times, right? So that could be interesting. Or same thing in our video grid, we could draw the different little kind of stamps, little video stamps, but instead of being the full video just smaller, maybe it's just different portions of the video, different kind of parts of it, but taken at different times in the video file to create this kind of jigsaw combination of all the different times that play through the video. So let's explore how that would look like. So in order to enable this, we need a way to record the frames that we draw on the screen so that we can recall them later. There's going to be a limit to how much we can do this. That's going to be defined by how much memory we have to play with. So this probably makes sense for short-ish video files, but if you put in a feature-length movie in there, you might run into some issues because what we're about to do is create an array that is going to store all the video frames that we get as P5 images. Okay, and we're going to create that array and call it buffer. So this will contain all our video frames as images. Okay. So what we're going to do is we're going to basically play through the video once instead of looping it. So instead of loop here, or actually, scratch that. I'm going to delete this, and I actually want to remix this project so I have both versions. So give me 1 second here. We're going to call this video buffer. Okay. Let's leave that alone. Okay, so now that I've remixed it, we are going to mess with it. And good thing I remembered because I almost overwrote my previous example. So what I was saying is we are going to record all the video files that we get, right? So in draw here, we're just simply using the current video image using the video object. And what we're going to want to do is as they come in, we're going to record, grab the frame, put it into the array, right? We're going to kind of build our own sequence of images, and we're not going to actually use the video object to draw anything. Instead, we're going to use these recorded images. So that means we're going to just simply play through once, Okay. And as the video plays, as we get new images in Draw, okay, so we're going to now have kind of two different sections. We're going to have a record section, record the frames as they come in. And then down here, we're going to do different renderings based on our whatever function we selected. Okay. So if we're going to record the frames, we're going to need some kind of variable that's going to tell us, should we be recording or should we stop? Okay. And because we don't want to keep building frames into that array, because over time it would get huge, and we only need to record as many frames as we have in the video file so that we can then start to play with it. So let's create a Boolean variable called record, and we're going to set that to true. And in Draw, we're going to say if we should be recording, what we are going to do is we're going to grab a copy. Let's call it frame. We're going to grab a copy of the video image. And the way that we can do this is we are going to say video.get. So in the image object in P5, the get function allows you to either get an individual pixel if you give it just one coordinate. So this would be the value of the pixel at 0, 0. Or if you give it a size afterwards, like video width, video height, it grabs a sub-region of the image. In this case, it's going to be the entire image, and it returns it as a brand new image object, essentially a copy. Okay, so make a copy of the image. And the reason we have to make a copy is that we cannot simply add the video object into the buffer because the video object, as the movie plays, right, its content gets constantly overwritten by the current frame. So I'm going to say buffer.push frame. Okay. Add it to the buffer. Okay. And while we're at it, since now we have an actual image that we can play with, because odds are, in this case, the size, right, of our window might be either smaller or bigger than what we have than our video file. Let's throw in a resize here so that the frame that we are saving actually matches what we determined was going to be our video width and video height, so that we're not going to have to do these resizes on the fly all the time here. Okay. So we're going to resize that frame image to match video width and video height. Okay. So if I hit record here, might get some errors. Let's see what errors we got. Okay. I'm also going to comment out slit-scan for now. Clear. All right. All right, so let's print out some stuff here in the console to figure out what could be going wrong. I suspect our video object has been created, and if we do this, we should be getting an image back, right? And that image should have a resize should we want to use it. Oh, interesting. Oh yeah. It's been resized. Okay, so then let's throw a log in here just to see what happens in our to our video file. So we get this error if the result here was undefined. Okay, so if it was not able to grab the sub version of the image, we're going to get that error. So let's clear this, hit refresh, and log the video object just to see what we get. We're getting a media element. Let's log the frame object. So what we got back was simply an array with 4 values. Interesting. Oh, I see. So this could be happening, this error here is happening before the video file was loaded, perhaps. So video width and video height would not have been defined quite yet. And also, this should be video.width and video.height. Because the size of the video file is not based on these variables just quite yet. So I think what we need to do okay, so we got an image back, but it's a weird size. What if we told video to load pixels here? Okay, interesting. So I guess video.get, pardon me, kind of relies on the pixel array being defined correctly. Because without that line here, make sure the pixels array is loaded, that function returned something strange. Okay, so let's not worry about it too much. And let's hit refresh. Okay, we're no longer getting some errors. Good. Let's put the slit-scan function back in. Now, this is going to work in the beginning. Where are we getting this error? Okay. So this is going to work if let me switch to a shorter video. It's going to look like it's doing the same thing, which that's because it is. And we're not yet using our buffer here. Okay, there we go. We're not yet using our buffer. We are simply using the video file inside slit-scan. Okay, so what we might want to do is at some point this is going to stop, right? Because we're going to run out of pixels for the number of it's no longer animating because we've run out of pixels and this video is only playing, right? It doesn't have a loop, right? When we set it in the beginning here, we told it to just play once. And actually, before we talk about that, the other thing we have to do is we got to be careful about this buffer here, because if I do console.log buffer.length, okay, you'll see that this is growing quite large. And in fact, it's starting to run into out of memory here. The screen went black. That can happen when you're running out of memory inside Chrome. So we need some kind of mechanism to stop recording when the video is done playing. And the way we can do this is we can define a little callback here on our video file. We're going to define it in the video loaded function. And we are going to say video.onEnded. And this is going to be a function that's going to runs when the video is done playing. Okay? So there's a number of callbacks we can define like this. We had the loaded callback, and then once we know our video is loaded, we're going to define this callback that's going to run when the video is finished loading. And we're going to define it right here. Let's call this video ended. And when that happens, we're going to set record to false. And we are just do a little log here. We'll say video ended. And let's say Let's put a little log so we know how many frames we've recorded. And something interesting is going to happen here as well, and we'll talk about that in a second. Okay, let's do a refresh. So now we can't see it, but it's playing through our video file, right? It's loaded the file. This is the original size, right? And then it's saying video ended, and it has recorded 0 frames. Why is that? Record is set to true. So we should be adding some frames here. Okay, so we see we recorded 307 frames. Okay, good. There's still like some weird stuff happening once in a while, so just to be on the safe side, we are going to do a little check here, and we'll make sure that if video is undefined for whatever reason, just abort mission, because I think that's happening erratically, and we'll throw that line in there just in case. Okay. Yeah, interesting. Anyways, moving on. So now we have this buffer here that we filled with images, okay, and we're getting about 300 and so frames. So what we could do is just to update our slit-scan algorithm in our video grid. What we also need to maintain now is some kind of our own playhead through that buffer. Okay? And what the playhead is going to be is basically just like an index. Okay? And we're going to say start at 0. And now that we have this buffer of images, right, we can play back through them by manually increasing the playhead. And we are going to do that in draw over here. So we're going to increase the playhead. Okay, so we'll say playhead plus plus, and if playhead is greater than buffer.length, we are going to make it equal to 0 again. So it's going to constantly just wrap around in all the frames that we actually have to that are available to play. Okay. And let's see if we get any errors doing so. Nope. All right, and then in our slit-scan function, rather than using video as the source, let's call this current frame. We're going to say buffer playhead. Yep. Or in fact, we don't need an intermediate variable. We're just going to go and say buffer playhead. And we will do the same thing here in the video grid. Interesting. Why do we keep getting this error on line 57? Or it is struggling here to resize the video image because it's got an image that had no height. It's not something I ran across before, so let's try to figure it out as we go. Doesn't do it every time too. You have to go greater or equal to here. I think that's what happened. We went 1 over. And maybe our problem will go away if once we fix the black few frames in the beginning. I think that might be related to that issue as well. So let's tackle those and see if the problem disappears. Now, I want to point something out here real quick. You may notice before, if you were observant, we were getting like a few hundred frames. Now we're getting 400. We got 300 something before. It's not always the same number of frames, and that's because once the video HTML element starts playing, it's not necessarily in sync. It's not, well, not at all in sync with our draw function. Okay? So depending on how long we're working inside draw, once we get to the next iteration of draw, what we capture is whatever is available inside the video object. Okay? So currently our frame rate in our sketch may not actually match the frame rate of the video, which is very likely. So the first thing is, well, let's do frame rate 30. So we'll match the video frame rate, okay, so that we're not kind of capturing some frames twice if we don't have to. And we may end up in a situation where, in fact, we may have a frame rate that's going to be a bit less than 30 as we're doing all this resizing, depending on how fast your computer is. So see, now we got only like 271 frames, and that's fine. So the long story short is that you may drop a few frames here and there as you're recording that buffer. But then once the buffer has been recorded, it should be pretty fast to play back through it. Okay? So that's what I meant in the beginning by this is not so much for like super accurate video work. What we're trying to do here is get more like different textures and different interesting results out of treating the video file as a data set for time. Okay? All right. Okay. And just to be on the safe side here, we're also going to put an if statement, and we'll say if we do have some frames, because it's possible that in the beginning, as it takes a few seconds to record some frames, we're only going to do that stuff here that's going to attempt to draw the frames using one of our algorithms and then increase the playhead if our buffer has at least one frame in it. Okay? So this is going to make sure we have frames to draw. Okay? All right. So let's try the video grid, see if that still works. Looks like it does. Okay. And one thing that's going to be kind of interesting here is the, in the case of the video grid, if we wanted to speed this up now, like when we resize our frames here, right, we could take into account this grid width and grid height if we wanted to. So we could create some smaller frames just to make it perform a little bit better. Like for example, if I divided this by 5 here, I'm just going to quickly do it, but this is not really the point of this particular demo. We're going to make the files even smaller, the images even smaller. And then once we're done kind of recording our video, oh, interesting. Yeah, anyways, we don't really see them play back faster because this would only impact the live version. Okay, so never mind. All right, so once in a while, we're going to get, let's get rid of this log, we're going to get a few black frames in the beginning and just, I'm not getting any now. Here, there we go. We got a few black frames, and those will be annoying to deal with if we include some black frames in our buffer. So we're going to make sure we don't save these frames, and the way that we can detect this is we're going to look at the pixels, and we're going to look at index 3. Okay? Now, if you remember index 3, what that means is the video pixels, right, are R, G, B, and A values. So index 3 is going to be the the alpha value, right? The alpha value for the first pixel in the array. And it turns out that those weird empty black frames we're getting, they're just full of zeros in the pixels array. So if we have an alpha of 0 for the first pixel in the array, right, it means that we have one of those frames that we want to ignore. We don't have any alpha 0 pixels typically in the videos that we're going to play. They're not transparent or anything like that. The alpha value is always going to be 255. So this is going to make sure that we only record actual video frames and get rid of the glitches that sometimes happen at the start of playback. So we're going to ignore by ignoring alpha values of 0. Okay, so only if we have an alpha value that is not 0 will we record that frame and save it to our buffer. And that's going to ensure that never again are we going to see the sort of things that we would see before with these kind of blank frames in the beginning. So the cool thing that we have now that we didn't have before is we have this buffer. Okay, and when the frames are being recorded, we now have an array that contains 270 images in this case, right? That is our entire animation sequence. So we could play with this and create some interesting renderings that will take advantage of time along these different axes. So we're going to create a version of our video grid here, like so. And let's call it fluid video grid. Yeah. And we're going to use that code here instead of video grid. And the idea here is rather than rely on the image being drawn over time, like we were doing in this example, we are going to draw all the numbers, the total number of images we would need to draw to fill out the grid. And at each location in the grid, we're going to pick a different place in time in the buffer, okay? Counting backwards from where we are in the playhead. We're going to kind of go back in time, in this case 25 frames, because we have 5 rows, 5 columns. We're going to go back in time 25 frames, and then each successive image is going to be a different image in the sequence. Okay? And then we're going to draw this as a grid just to see what that would look like. Okay. So let's write a for loop here. So we're going to say, first of all, we're going to reset x and y to 0. And then we are going to write a for loop that's going to say, repeat, use I as a counter, and the number of repetition is column time rows, increase in steps of 1. So I'm going to do it like this, and indent this. So hit refresh. Okay. So we have 5 rows, 5 columns. Why does it stop here? Y is greater than the number of rows. Stops here. Do I need greater or equal then? Interesting. Okay. All right. So we got our grid here. And now what's happening is we're playing the same image, right? Whatever buffer.playhead is in every slot of the grid. So we could play around with this and we can say, let's take this image, that's our current image. We're going to play that over here. But then as we move back into the grid, right, we're going to be taking previous images so to kind of create this sort of video delay effect. Okay. So let's capture, let's create a variable. We're going to call it index because I is already taken. Okay. So our index, we're going to say take buffer.length, right? And we're going to subtract the counter from it. And then we're going to add the playhead to this because our playhead is moving us forward in time. Let's do it in the opposite way. We're going to say add the playhead and then subtract the counter. guess it doesn't really matter which one we do first. Now, if we do this, we got to be a little bit careful because we're doing 25 images here, and in the beginning, we're not going to have 25 frames, so we might end up with a negative number here. So what we need to do is we need to use what's called a modulo operator to make sure that our index remains within the bounds of the buffer so that we kind of just wrap around and always remain positive. Now, in those of you coming from processing, you might be familiar with this syntax where we might say index equals index modulo buffer dot length. Okay? And this works in Java because this percentage operator in Java is in fact modulo. But in JavaScript, it doesn't have the same meaning. The percentage operator is remainder, which sounds similar, but it's not. So both of them give you the remainder of a division. The difference is that remainder can go negative and modulo can't. Okay? So we're going to work around this by creating our own modulo function. And I'm not going to get in depth here into how this works, but we are simply going to kind of create our own version of the modulo function so that we can take a modulo and we can stay positive. Just find it in my reference here. Okay. So I'm just going to grab it from another example. So this function looks something like this. And so this will give us the true modulo of a number by a certain value. Took me a little while to figure this out because I assumed the percentage sign in JavaScript would do modulo and in fact doesn't. So with a little bit of research, I ended up finding this function, which works great. So we are going to do, where was I? Fluid grid here. We are going to say index equals mod index buffer dot length. And the purpose here is make sure we're going to wrap around if we exceed buffer dot length. Okay. And then here we're going to use index rather than our playhead. Okay. So now we're drawing our entire video, right? Except we are shifting each tile in time by using a different index that's an offset from our playhead. And that's kind of neat because it allows us to create this sort of video delay effect where now we can sort of see multiple facets of what we were looking at. Normally we would see one frame in time. Now we've stretched that over a longer period based on our the size of our video grid. Okay? And of course, if we increase the size here, we can make smaller tiles. And you can see it gets a little bit glitchy in the beginning as we fill our array with images, right? But then once the array is complete, we can definitely loop through it, and it's a cool little effect. Okay. The other interesting thing we could play with is rather than repeating the same image over and over, we could say this tile here is going to take one portion of the source image, right, the top left corner, and then draw that at a certain point in time. And then that's going to take the next portion over, so that we're always seeing the full cat, except the grid will show us different times, right, in the buffer. So how would we do this? Well, here, this is showing us where we want the cat to be on the screen. So we know that, so let's put a comment here. This is the video loop effect, video delay, I guess, effect. If we took that same line and then added this twice, okay, what's going to happen is that this is also going to sample that location in the source image. So now I'm going to do the same thing twice, and this is going to sample subimage for the grid. I don't know how to describe that better. Let's hit refresh and see what it looks like. So now we can see the cat, right? The whole video frame, except our video frame is broken down into a grid, and at each location we are taking a piece from a different image in time. So we have 25 successive images We are moving through the buffer using playhead, so this just kind of loops through the buffer. And at any given time, we kind of go back 25 images in the past and then create this kind of weird, freaky composite of the cat as a result. And you could make the effect stronger by, changing the size of this grid, for example, so we can see like a lot more time is being shown at once. Still all the same frame though. So this is a fun idea because now we can also kind of apply this to the slit-scan concept, sorry. This fluid video grid. Like basically all the slit-scan does is it takes a really kind of skinny portion of the video grid, right? And a skinny portion of the image, and then repeats that over and over. So we could try to attempt this if we imagine that, we're going to have the number of columns, right? What if we had one column, right? So this is our rows. Actually, no, we're going to have one row if we wanted to have it horizontal the way we had it before. And the number of columns we are going to have is going to be the width of our video. Let's see what that looks like. Interesting. So that's going to create an interesting effect, but we can see there's like a repetition here happening. And I think I know the reason why is because we only have 218 frames to play with. And in fact, here we have more than 218 pixels. So if we wanted to recreate the slit scan effect, we would need to make sure that the number of columns does not exceed the number of images we have in the buffer. Okay. So how would we ensure that? We would say here more columns and rows than we have images in the buffer. We will say columns equals the smallest of either buffer.length or or columns. And just in case we experiment with the same thing here with the rows, we're going to do it with the rows so we don't have to redo it. Let's see what that looks like. Oh, cool. So now what we get is kind of an animated version of the slit scan effect, where now the cat's movement is kind of fluid over time, and you can see this cool animation of the whiskers as he moves. So that's a neat effect. We could let's put a comment here. Let's call this vertical slit scan. This is an image grid. Put little comments here so that we can experiment with different versions of this idea. We're going to call that one horizontal slit scan just to see what would happen if we applied it the other way around. So this we could make it 1, and this we could make it video height. And I'm going to comment these out, and then let's hit refresh. So now our lines will be kind of upside down here. I mean, straight lines going across. And that's going to look kind of cool too. As the cat turns its head, it's going to give the illusion that it's sort of twisting. So you can create some really neat effects with this technique. Just for fun, let's try it with a different video, like the hamburger lady. See what that would look like. So as we're recording all the frame, the resolution gets a little bit greater. And now we're kind of doing something similar to the slit scan, where we're drawing kind of these very slim horizontal lines. The difference here is now that every row in the slit scan is being animated because we are scanning through our buffer. We're able to do this because we recorded all of those video frames that the video contained, and now we can manipulate how we display the video. We can show different parts of the video at once inside the same frame. So it can get pretty mind-bending and trippy to play with this. Let's take a look at the commuters one. This is the people walking across the street. This one also creates an interesting effect where you can sort of see the legs stretching across, and then depending on which way people are going, you can still you can still make up some people in the crowd, right? Depending on how fast they were moving or if they were standing still. But then that gets blended in with these sort of stretch versions of people, creates this really weird, funky texture. And we can also try it out on this other time lapse just to see what would happen. So once we play the time lapse, this one is interesting because it's not moving as much, the content of the frame. We just have these kind of cranes that are moving in the background and some of the boats. And they just now move in this really interesting way. Same thing with the clouds here. And then as the time lapse kind of progresses, we're going to get into the nighttime, and then we'll see the image, kind of the night slowly taking over from the top here. And then we'll have this hybrid version where we see both daytime and nighttime together in the same frame. So now we loop back to the beginning of our buffer, right? And then we're drawing lines from the beginning and from the end. And yeah, it's kind of a neat, interesting effect. So for the exercise this week, I would encourage you to do a few things. One is obviously you can experiment with some of these, trying to say either the static version of the fluid version, grabbing different video files to see what happens if you can create a cool effect. You can also, if you're feeling more adventurous, now that we have this buffer of images, right, what are some other forms that you could use to render either the whole buffer or different parts of the buffer in one frame? For example, the static slit scan version could be interesting to explore. I'm gonna go back to this one here. The static slit scan version could be interesting to explore as a line, perhaps, right, going around a circle, kind of the way like a clock might operate. So lots of cool little visual experiments you can do now that we have this array of images to play with, the buffer. We have the playhead, which is simulating playing through the array the way a movie would. So for the exercise, yeah, you can make it as elaborate or simple as you want. You can stick to the existing algorithms, tweaking them a little bit, trying different video files, or come up with your own rendition. There's lots of depth to explore here, and hopefully you have some fun with it, and I'll see you next week.